Underlying concept for finding the number of factors. What is the number of factors of 240? So if you were to do this manually, it would take a lot of time. 1, 2, 3, 4, 5, 6, 8, 10, 12, and many more. There is a possibility that you will end up missing some factors. So there has to be a smarter way out. The concept is, first of all, break the number into its prime factors. So factorize the number into prime numbers. 240. How you can do it quickly is first remove the 0. 0 can be replaced by 2 times 5. Then 24 is 2 to the power of 3 times 3 to the power of 1. So it opens into 2 to the power of 4 times 3 to the power of 1 times 5 to the power of 1. Step 2 is to add 1 to each power and then multiply all the terms. Why add 1? Try to understand what is going on here. We have 2's, we have 3's, and we have 5's. If 1, 2, 1, 3, 1, 5 are taken and multiplied, some number would be formed, which would be a factor of 240. If 2 2's, 1, 3, 1, 5 are taken and multiplied, they would lead to a different factor of 240. So it's about figuring out what is the number of combinations of selecting among 4 2's, 1, 3, and 1, 5. 4 2's can be selected in how many ways? 1, 2, 2 2's, 3 2's, 4 2's, and there's a fifth case also, of no 2's at all. So 4 2's can be selected in 5 ways. 1 3 can be selected in 2 ways, 1 3 or no 3. 1 5 can be selected in 2 ways, 1 5 or no 5. That is why 1 is added to each power. So 5 times 2 times 2, which is 20. And therefore 240 has 20 factors. Try these questions. Please pause the video and solve these yourself. 1500 can be broken into 5 times 3 times 5 to the power of 2 times 2 to the power of 2. They combine together to form 5 to the power of 3 times 3 to the power of 1 times 2 to the power of 2. Now add 1 to every power and multiply. 3 becomes 4. 3 raised to the power 1. So 2 raised to the power 2, so 3. The number of factors is 4 times 2 times 3 equals 24. Remember, one step is very important here, which is to combine the powers 5 times 5 to the power of 2. It is important to combine it to form 5 to the power of 3. If I had not combined, imagine the powers would have been 1, 1, 2, 2, and I would have multiplied 2, 2, 3, 3, and I would have got a bigger answer, 36, which is not the right answer. The right answer is lower than that, 24. So always combine the bases, and of course make sure that every base is a prime number. 720. Let's break 720. We get 2 to the power of 4 times 3 to the power of 2 times 5 to the power of 1. We just need to add 1 to the powers and multiply. So it becomes 5 times 3 times 2. The number of factors is 30. In the third case, the bases are already prime. You just need to add 1 to the powers and multiply. So 5 times 6 times 4 times 2 times 5 turns out to be 1200. In the last case, you have to break the numbers into prime bases. This is what it simplifies to. Remember to combine the same prime bases for adding the powers. It simplifies to 2 to the power of 9 times 3 to the power of 5 times 5 to the power of 4. Add 1 to the powers, we get 10, 6, 5. The number of factors is 300. This was the concept, friends. GMAT shots are deliberately kept brief. For an elaborate explanation, please watch the Stage 1 conceptual videos in our program. Thanks for watching.